Hello everyone. I hope this video is finding all of you safe and healthy, and I've gotten lots of great feedback from several of you saying these videos are helpful and you're understanding the material. I've also gotten some really great questions from some of you who have felt like you've been confused on a few things, and I think that we've been able to also get that cleared up. So I just encourage you to reach out if you are confused on anything. And I'm more than willing to try to get things cleared up for you. So we're going to start section 12.3 today. Once we finish section 12.3, and there'll be 2 notes pages to this section, we're going to kind of break and have like a little sort of mid-chapter assessment or small test over this. So we've been talking about right triangle trig. We were introduced to radians and how to find arc length. These problems, when you read the problem, it sounds like it's a lot more complicated than what it actually is. Okay, and in fact, I'm not really going, there's nothing wrong with this material up here, but I'm just going to have us sort of draw little sketches of these, excuse me, particular problems. So I'm just going to start with the first problem here. We'll just kind of dive in here. It says the terminal side of theta in standard position contains the point -3, -4. Okay, and here's what that means. When it says the terminal side, using the picture up at the top, we know that when we draw an angle, the terminal side is always that other ray where we're not sure where it's going to land until we know what the angle measurement is. Okay, the other ray is what we always refer to as the initial side, and we always know that that is definitely going to be placed at the positive side of the x-axis. And so this problem is saying that if you were to draw an xy axis, and of course we know that the initial side is definitely going to start right here, it's telling us the terminal side is going to run through the point -3, -4. So if I were to plot the point -3, and I'm going to just put some little markings here, -3, -4, okay, that's going to be right there. It's saying the terminal ray goes right through that point. So that tells me where my terminal ray is, okay? Now, what you're going to do once you have your angle drawn is you're going to finish sketching the triangle, okay? And you're going to sketch the triangle so that from that point, -3, -4, you're always going to draw a perpendicular line from that point to the x-axis, okay? It's always a perpendicular line from the point to, it's always the x-axis, okay? That's the important part there, always to the x-axis. Okay, and then when you do that, you can see that there's this triangle that's formed, okay? And so one of the things that we want to make sure that we're doing on our triangle is we're going to put a little theta symbol. That's like this little Greek letter, the alphabet here, that theta symbol. We're always going to place that inside the triangle at the angle that is nearest the origin, okay? The angle that's closest to the origin there. Okay, so I'm going to put the theta symbol right in my triangle closest to the origin, okay? And then I'm going to take the fact that the point was -3, -4, okay, and I'm going to label, now this is where it's going to feel a little bit weird, I'm going to label the horizontal leg of my triangle as a -3. And I know that's odd because usually when we talk about a length of something, we usually don't refer to lengths as being negative, but this is more kind of telling us what side of the x-axis this horizontal leg is on, and because it's sitting on the negative side of the x-axis, that is why I am labeling it as a -3. And then the vertical leg, which in my picture is colored green, that vertical leg is technically on the lower half of the y-axis, and so I'm going to label that as a -4. And what you'll notice is that I use the exact same 2 numbers that I was given in my point, okay? Once I have those 2 legs labeled in the picture, I am going to use the Pythagorean theorem to find the length of the hypotenuse. Okay, and what I'm asking is that you at least show this as the Pythagorean theorem, like show that substitution. If you want to do the rest of the work on your calculator, totally fine. That would end up being 9 plus 16, which would end up being 25 equals c squared. So we would get the hypotenuse to be 5. Okay, now here's another very important note. When you add the hypotenuse to your triangle, the hypotenuse is always going to be a positive number. No matter where your triangle is positioned, no matter which quadrant it's in, always label the hypotenuse as being positive. Okay, once you have the hypotenuse labeled, you're now just going to go through and you're going to build what your 6 fractions are, which this is what we've been talking about before, how these are all just the reciprocals over here on the right, and it's the SOHCAHTOA here on the left. So I'm not going to talk through that part again because we've been through that. Okay, so just to look at one other one here real quick that's similar to this, I'm going to start out, I'm going to draw an XY axis. Okay, I'm definitely putting the initial side here. I'm going to take a look at my point. Okay, the point is -6, +2. Okay, so I'm going to mark off 6 markings to the left, 2 up, and I'm going to plot the point -6, -2. Okay, that tells me my terminal ray is going to run through that point. Okay, once I've drawn the terminal ray, I'm now, remember we said up here, you're always going to sketch a perpendicular line from that point always to the x-axis, okay, and this completes your triangle. Okay, when you have the triangle, put the theta symbol in at the origin and go back and look at your points and label the x value was -6, so that means I went to the left 6, so my horizontal leg is -6. The y coordinate is +2, so I'm going to label the vertical leg as a +2. I'm going to set up the Pythagorean theorem here. I could do the rest on my calculator. Please keep in mind that if the number that you're taking the square root of is not a perfect square, do not write this as a decimal. Instead, leave the hypotenuse as the square root of 40, and then we would just hop over here and we would squeeze in like all of these fractions here. Okay. Again, there's like not a lot of room here. I'm really sorry about this. I'm kind of really squeezing this around here. Okay, I think this one for tangent, I could reduce that to -1/3. So when I do cotangent, I'm just going to do the reciprocal of -1/3. Okay, and this other one here down here is done for you. Okay, all right. On the next page, we're going to talk about a term called a reference angle. And what a reference angle is it's always an acute angle. Okay, so that means it's always going to be an angle smaller than 90 degrees. So you should never be saying that a reference angle is like 105 degrees or 200 degrees. Okay, it's always an acute angle, and it's the angle that's formed from the terminal side of your angle and the x-axis. So I've got these 4 pictures here at the top. And in each of these 4 pictures, you can see that the terminal ray is landing here in quadrant 1. Here, the terminal ray is landing in quadrant 2, 3, and 4. Now, I'm going to use a highlighter and highlight what the reference angle is. If you don't have a highlighter, you can maybe just take your pencil and sort of shade it in. What you want to know about the reference angle is it's always going to be positive. And technically, it's that little gap, that distance in degrees that your terminal ray is from the nearest side of the x-axis. And so in this first picture, the reference angle would be this little angle right in here. Okay, see how that's the closest side that terminal ray is from the x-axis. It's closer to the right side of the x-axis than it would be like all the way over here to the left side of the x-axis. So our reference angle would be that little space that I highlighted. Now, if your terminal ray lands in quadrant 2, well, now my terminal ray is much closer to the left side of the x-axis than it is to the right. So I always want to pick the acute angle. If it's closer to the left side of the x-axis, I'm looking for that little gap. If it's closer to the right side of the x-axis, then I'm looking for that gap. So if it's landing in quadrant 3, this would be the reference angle. And if it's in quadrant 4, that would be the reference angle. Okay, so what we're going to practice is we're going to practice sketching an angle And then after we have an angle sketched, we're going to say this is what the reference angle is. Okay, so looking down here at example 4a, we are asked to sketch a 210 degree angle. Okay, now this is positive. That means we're going to go in the direction that is counterclockwise. I'm going to start with my terminal ray here. I know every quadrant holds 90 degrees. So if I'm going to go, here's 90, here I've gone 180. So I would want to figure out, well, how many more degrees do I need to go if I've already gone 180? Well, it looks like I need to go an extra 30 degrees down here into quadrant 3. And as I'm calculating that, that's kind of telling me what the reference angle is. Okay, so I have sketched a 210 degree angle, but the reference angle is this space right in here. And so how you're going to label this is you're just going to put REF with a little theta symbol and say the reference angle is 30 degrees. Okay, what you're going to do for example B, since that angle is in radians, you're going to first have to convert this out of radians and into degrees, and this is from a previous notes page if you need to look back at that. To convert out of radians and into degrees, we're going to multiply by 180 over pi, then we multiply -5 times 180, we divide that by 4, we get the angle to be negative 225 degrees. So I'm going to sketch a negative 225 degree angle. Okay, that means I'm going clockwise. Here I would have gone 180 that direction. So if I've gone 180 in that direction, I still have an extra 45 degrees that I need to travel in this direction. Okay, so there's a negative 225 degree angle, but the reference angle is just this space right in here. And so I would say the reference angle is 45 degrees. Okay. And then this one over here, a negative 110 degree angle. So here is going 90 degrees. So I'm going to take off 90 from 110. That tells me that I have an extra 20. Now here's where you have to be careful. When you're doing a reference angle, remember the reference angle is how far the terminal ray is to the x-axis, not the y. Okay, so the reference angle is this space in here. So if I've gone 20 degrees on this side, then that means my reference angle is technically 70 degrees. Okay? Okay, reference angle is always an acute angle. It's always going to be positive, and it's always the shortest distance to the x-axis. Okay. All right, so in this last example here, we're talking about a fair ride. It says the swing arms of the ride at the right are 84 feet. So you can see that labeled in the picture. It says the height of the axis from which the arms swing is 97 feet. You can see that right there in the picture as well. Okay, what is the total height of the ride at the peak of the arc? So the question is, we want to know what is this whole distance right here. Well, if you look at this picture, you can see that we basically have a triangle here. What they didn't mention in the picture, or in the problem, but you can see it in the picture, is the ride swung negative 200 degrees in that direction. Okay, so if it went negative 200 degrees, then that means this gap right in here would have to be 20 degrees, which is what we now know is the reference angle. Okay, so this is nothing more than if I can find the length of side y in that triangle, and it looks like I'm going to want to use sine because I want to use the opposite leg, which is y, over the hypotenuse, which is 84. I'm going to cross multiply. That's going to give me side y to be 28.73 feet. And the question is, what's the total height of that ride at the very peak of the arc? It's getting ready to swing back down again. So I need to add the 28.73 to the 97, and that gives me 125.73 feet as the total height of that ride. There is a problem on your homework. It's number 36. It is kind of similar to this problem. I'm asking that you try your very best on that, but you would want to look at example 5, and you can see down here in example 6, they didn't give you the picture, but you could easily kind of sketch the idea of the picture based on how the previous example looks, and I worked that one out for you just so you have a second one to look at. Okay, reach out if you guys have questions. We will talk to you later.